what's up, goobers? Yeah, today we are back making, more iterations on the forced hydration machine, which, I'm sure that y'all want to type the command in, so let me actually just skip right away to the Havesies view. Okay, let me get my avatar showing up in this. Actually, let's reset the transform. You can see SteamVR being silly here. Okay, and the GoPro view. Why are you not showing up as a webcam right now? GoPro. I really need to make like a checklist before going live, because there's like a ton of tech that goes into this. And there's always one or two bits that I always forget to initialize. But, okay, let's unplug and re-plug in the GoPro. USB connected. It should say it's a webcam soon. Alright, that should start working very soon. Yeah, okay, cool. Alright, and let me go adjust the GoPro's view. Okay, so last stream we made a thingy that whenever you type in !hydrate into the chat, then it's supposed to dispense water that I'm supposed to drink. Actually, let me go put the water tank in view also. Yeah, it's looking a little bit different since we streamed the build process last Sunday, so I'll go point out what the differences are now. Okay, I can move this a bit more to the center. Okay, so here's some differences. Before we had the scale part, or actually, let me do like a breakdown of what this is for anyone that's tuning in new. Okay, so this is a machine that whenever you type in !hydrate into either Twitch or YouTube, I'll go do one and then the other. So this is hydrate on Twitch. Oh wait, I have to reboot it. Okay, it is rebooted. I like the part where, whenever I start a project, or whenever I, like, try to demonstrate a project, on camera, it doesn't work, even though it's been working, like, the whole other time. But, okay, so, yeah, I think it needed a recalibration on... Oh no, why is it not working? Okay, is anything unplugged here? Why is it not detecting that there's a glass on here? Well, it's a good thing we're working on this project right now to make it work better. But let's try recalibrating again. Okay. That's weird. It's not detecting glasses on here. Oh, now it is. Or maybe the weight calibration is off. Okay, so let's actually go plug in this thing to you get a USB cable for that. And then we can see what's going on. Because it literally worked like 30 minutes ago. But we should be able to get some debug logs to figure out what's going on here. Okay, and might as well switch to office mode. Oh, no, sorry, avatar mode. this working? Is this working? I think I lost connection for a bit. Not sure why that happened. Because I'm not connected to Wi-Fi right now. I am connected to Ethernet. But let's see what's going on. Okay, I'm gonna go run the monitor. Here, run monitor. Huh. That's weird. Hopefully it'll be fine over the next few minutes, because it was just like a sudden dropout, and then back to normal, I guess. It says that my connection's kind of strong right now. Okay, so... is this even detecting this right now? Or no, sorry, it's PO device monitor. There we go. Okay. So, it says that there's no glass on right now. I'm gonna put this on. Okay. That was weird. It wasn't working, but now it is working. Okay, let's try again. Let's force the camera to stay on the workbench mode right now. Okay, so if I type hydrate... Yep. Y'all missed that. Y'all missed that. But, yeah, we see the water level's a bit higher. And I want to demonstrate it again. And I'll demonstrate it on Twitch because it responds faster. But yeah, this is what it does right now. And so it's really basic. What we have is we have a pump up here, and it's USB powered, and you can actually see the USB that powers the pump itself is here. And then we have a microcontroller down here. It's an ESP32S3, and that connects to the internet. That actually talks to Twitch directly, and it talks to a YouTube proxy, which was not working the first stream, but works now. And that's what collects the messages, and then whenever it detects hydrate, then it activates the pump. And down here, we have a scale that measures the weight that's on here, and so it does kind of two things. It checks if the glass exists in the first place, so that we don't fill into nothing. And then the second thing is it detects if the glass is full. And so there's a couple different things compared to last time. First thing is the reservoir is now using this 1 gallon jug of Texas water, and before I was just using like a big, I think carafe is the word for it. Maybe it's carafe, I don't know how it's pronounced, but that was only like a quart or so, and now this is like a whole gallon, which I think is like 3.8 liters in like metric. But yeah, so yeah, we have an actual top on this, so it doesn't really spill so much. We have a little hole here with a little PTFE tube that you might recognize from a 3D printer. That's just for the air to flow back in. And so yeah, this is the first change. Just kind of keeps things easier to organize. Second change, we have this ultrasonic sensor here. It's not doing anything right now, but we wanted to do something during the stream. And so that's because there is this edge case where if you typed, or no, sorry, not typed. So there's an edge case actually, which this is actually a perfect thing to demonstrate with, where if you turn this on, it's expecting this to be empty so that we can get a weight when there's no cup on there. but right now has no way to actually detect if there's no cup on there to start with, because it needs to calibrate first. And so this will tell us if a cup already exists on the scale, and if it does, we will be told to take it off of the scale so that it can actually finish calibrating. In addition, if I thought about having a thing where if we detected that the cup was already here, but if we detect the cup is here with the sensor, and then decide to calibrate it with the weight of the cup accounted for, this does not actually know if there's already water in here. So if I were to start this up and it calibrates the scale thinking that there's an empty cup on here when it's a partially full cup, then that means, because we have the ultrasonic sensor to know that there's a cup on here to begin with, but it assumes it's empty instead of knowing it's partially full, then we have an issue where it can actually overflow because it thinks that this is an empty cup. So then once it fills past halfway, it thinks that it's halfway full, and it just keeps going and going, and then makes a mess. So we don't want that. So that's what this ultrasonic sensor is for. And I added that between the two streams, just so that we could kind of get like a head start on it without having to like wait for it to print. And then the third part is just to make it nice and self-contained. The scale is now integrated into the base of this hydration machine. Before it was kind of just free-floating, which meant that like if I move this around or move the scale around, there's a possibility that the wires will get torn off, and that's not good. So this just keeps it all nice and self-contained. But yeah, I guess just for a lineup of what these light indicators mean, green means that we're currently connected to Wi-Fi. Solid purple means that we are connected to Twitch. Solid red means that we're talking to my YouTube proxy. It doesn't necessarily mean that's actually reading the YouTube chat correctly, but it means that the proxy is online out anyway. Because long story short, this ESP32 can't talk directly to YouTube and know what the current live video is, so I need a proxy to do that for me. This green one, I honestly forgot what that does. And this yellow one tells us what the status of the scale is. So it's yellow right now because there's nothing on here. And when I put the glass on here, it should turn to green, meaning that it's ready to dispense. So let's hydrate again until this thing is full. And when you go put a towel, just in case it's about to overflow. Hopefully it doesn't, because that's what the point of the scale is, but, this thing also may not be the best calibrated right now. Okay, it says we're at 90% full, so there's a good chance that this... Oh, yeah. Okay, yeah, now it says that's full. So, that's why this is red now. And so if we call hydrate again, it's not going to fill anymore. And on Twitch, it's going to post a message saying that it's too full. Although I think there's kind of an issue with like cooldown times or something, because it doesn't actually give out the messages all the time. It gives it out most of the time, but not all the time, especially in rapid succession. But that's kind of a minor problem to figure out. But yeah, I have a big laundry list of changes that we're going to be making this stream. So yeah, let's go to the iPad view. And no screen view. Air server. Let's get you broadcasting again. Okay. And let's zoom in on you. Why is that like really pixelated? That's really weird. Oh wait, actually I should probably make that window big. Yeah, there we go. That's probably better. It's a little crunchy, but it'll do. Okay. So, I took a bunch of notes in my Discord server, which, actually, yeah, I want to show that. So, yeah, at my Discord server, which I'll go write the link to right now. And you should join my Discord if you're not already in it. discord.pearlgray.io. Okay, so yeah, this is my Discord server. I post stuff in it, and I have the project logged in here, which is where I'm taking notes offline. And so, yeah, here's kind of the to-do list, which I've been posting in here, which I actually just kind of start writing down anyway on the iPad. So, yeah, to do. We need Twitch to not reboot the whole thing. Reboot whole thing if error. Okay. And why is... Hold on, why is this so, like, blurry? Let me go make this not as blurry. Okay, I don't know why it's so blurry. Maybe I'll just make the, stroke a little thicker so it's more legible. Yeah, that's probably better. Okay. Now the rebooting thing with the glass, is definitely a thing that I just talked about. So, integrate ultrasonic sensor for cup calibration. And let's see, we don't have an overflow detection in case the load cell is wrong. That's part of that. Timer-based dispensing does not yield identical dispensing. So, change... Oop. No, don't. I wasn't talking to you. So change... Why are you... Change dispense from time to weight based. Let's see, next. It's not annoying enough, so add a beeper for alerts. Let's see. You need to add rate limits. Electronics can be leaked on. Let's see, there should be a few more. Oh, hydrate works when the stream's offline, which is kind of weird. When stream offline. So you want the Twitch bot to check if the stream's online or not. Oh, right. I wanted to add some physical controls on here. So the controls would change how much does a hydrate fill. Cooldown settings and overflow enabled. Oh, and just manual dispense. And then I think one more is ability to queue drinks up whenever the whenever a cooldown is active, but it'll be like, okay, we'll just queue you to dispense when the cooldown is done. But yeah. Okay. So yeah, that's what we want to do. I'm not sure if I'll get to all this today, but we'll get through a lot of it today. And let me go drink that water also. But yeah. Okay. So let's think of what's the first thing to do here. We also get a bunch of wires out so that we can start doing stuff. I think the first thing to do is that we want to move the electronics up high and maybe move the pump down low, because yeah, I don't want the pump to I don't like the pump being up here, and just because I know that just feels like something could eventually leak and just spray all over everything. I want the electronics to be up top, and the pump and any tubing to be lower than the electronics. Oh, there's also one more thing. We want to actually power the everything off a single USB port, because right now we're actually powering off 2 USBs. There's the ESP power going into the ESP32, and then there's a separate one for the pump, and that's just not good design. So yeah, we want all of it running off the same thing. So single USB port. Okay. Alright, so I think the first thing that makes sense to do is to move the pump, move the pump down, and then put electronics up and extend any necessary wiring so that the electronics can reach it at the top. Which means that this isn't going to work right now because I have to unplug it, which I guess I need to make that hydrate status thing say it's offline. Oop. Okay. Alright, so let's unplug everything. And probably move this out of the way. The tube's long, so I'm not too worried about it getting in the way. And then I guess just because I need quite a bit of room to work with, it's the safest way to do this. I think if I just unplug, because we're going to need to increase the length to the load cell for sure. Where are my flush cutters? There. So take off this hot glue wad. Okay. And then take off the scaffer's tape. And there's actually a couple things here that keep getting unplugged that I want to just secure in with a bit of hot glue temporarily, which we're eventually going to convert this into like a proper perf board. I'm not going to do like a proper like PCB just because like this is a one-off project. But yeah. Just kind of want to get this as far away as possible while we're working with the water, because I don't want to splash over it and then burn some stuff out or whatever, because that'd be annoying. Let me just put it up here, and then this will almost certainly make a mess. Put the towel down. Yeah, that's what I thought would happen. We're getting a bit of water leaking. Alright, just go on the towel. That's good. Oh wait, that's a siphon right now. Okay. Maybe we should just... I'll just cram this up here so that it doesn't go anywhere for now. Wow, this thing's already, like, full. I might need another towel already. Okay. So, I think this can operate fine with the pump being on the bottom instead of... Oop. Oh, that just fell. That's okay. It's probably not very fragile right now. Double stick tape. I was hoping to reuse that, but I guess not. Okay, if you want to test it, you should probably make it so it doesn't check if you're live when you hydrate. Yeah, that's a good call. Maybe I'll have another switch on it for like a test mode. Or I could have it like maybe just use a single button that cycles between like test mode, overflow mode, and normal mode. But yeah, that's definitely a good call that we don't want it to always enforce that we must be live for it to call hydrate. Okay. Moving the backing from double stick tape sucks. Okay. Cool. Actually forgot which end dispensed and which one doesn't. We can just switch it when we need to. I remember this being like a thing that we had to figure out during the first stream also. Okay, let me go get some zip ties, wherever you are, zip ties. You're not up on the shelf. Are you down here? No, those are brushes. Zip ties. And is this heating up? Okay. Well, that should be secure enough for that. Let me go check the Amazon listing for that pump, just to make sure which side was the pump side, which one's the source side. Okay, checking Amazon on my phone actually, so my face cap is dead for now. Okay. So... looks like that the center one is the output and the outer one is input. And we can just test that out also whenever, Okay, so center is output. And input is, although, is this gonna be a problem with the siphon effect? It might be, if it's too low. We'll see. Oh no, because this is still higher than the water source. Okay. Need to wipe that down. Alright. And... might make sense to just, like, start 3D printing, like, a little platform for this to hang. Well, we might actually not need to do that. Let's see what we have in here. That could work. Just tape it onto there. Yeah. The less printing that we have to do while live, the probably better. Because printing just takes time. Screwdriver. Oh, that was weird. That can't dispense water warning happened kind of late. Alright. So it doesn't have to be like stupid high up though. I think that those holes are actually a little too tight on here and they probably need to be drilled out a little. Okay. Drill. Let's got our 5.5 millimeter bit out. Okay. Yeah, that's loose enough for comfort. Alright. Okay. And then... this one here. It's gonna be like asymmetrical, but that's okay, because... Oop. That's okay, because this is just a prototype. It's not the final product. Okay, does that actually spin in place? It does not. Now that's spun in place. Okay, that should stay on. Okay. And then... just want to stick this up on here. And we can just use some of the built-in adhesive on here, just some of it, fold it back a bit. Okay. So that's probably secure enough. And then, I know we can just tape that on top just for status. Okay. So, relays. Where did you go? What pin were you? You were pin. Relay pin is 15. Turn on this light so I can actually see stuff. $15, where are you? There's 15. It's actually a little tricky to see with everything kind of in the way right now. Oh, I forgot to turn my face back on. Okay, face, you should be back on. And where are you? 15? I think that's 15. Okay. And then let's plug this into USB here. And where's another USB power thing? Up here. And then we can get the light status from here. Okay. So if we call hydrate... Oh, the load cell isn't plugged in. It's kind of important. Before we can retest everything out. And I think we're gonna have to extend this wiring, which is fine. I expected that. Yeah, we are definitely going to have to extend that. And I also accidentally sliced that up while doing this. So yeah, let me just chop that off. And we need about a foot-ish of wire. So let me go get that. Let's see. Black and... Wait, is this the heavy-duty wire? This is. I don't want to use that. Okay. This is a slightly thinner one. Black and red and green. And I think white was the last one. Yeah, white. Okay. I think that's actually like USB cable color scheme. I don't want to look for it. Plus, USB wire is like a lot thinner, and I don't like dealing with it. So yeah, we're just gonna extend the wiring and gonna go a little longer than we probably need in case I want to redesign stuff that needs a bit more length on that. Yeah, that should work. Just kind of eyeballing that. Okay. Then we're gonna splice these. I don't know if I want to sleeve these wires yet. I probably shouldn't right now. I should probably wait till we're closer to final product to do that. One, two. Let's trim that one off a bit more. 3 and 4. That hot glue gun was hot. Second one, I guess. And 3. I wonder how this, if resistance matters for the wiring, if we have to recalibrate stuff. Might have to. But yeah, let's just splice these. Oop. Should probably use the OmniFexo. Alright. Where's the lead-free solder. Lead-free solder, where'd you go? Not in there. Oh, it's back here. Okay, let me just set the camera permanently to workbench mode. That's dirty as hell. Oh no, disconnected it. Okay, red. That'll work. Black wire. Ow. That was close. Okay. This soldering iron wire is twisted. Let me untwist that. Okay. And let's heat shrink wrap stuff. Where are you, heat shrink wrap? You're not here. You are back here. Do you even have like the super skinny stuff left? Okay. 2, 3, 4. Alright, that's on. That's on. That is on. And that is on. And what's the temperature on the heat shrink? Okay, 150 should work. Wait. black. And then red. Okay. And then let's just crimp the wire ends. Why is this not turning off? There we go. Okay. Wire crimp connections. I wanted the female ends here. Yeah. Okay. So those are... I could... No, I don't know how to four-way braid. I'll figure that out later. Let's just trim those. And then crimp these after twisting the ends. Red. Okay. Alright, here's my crimpers. Alexa, fans on. Oh, they are on. They're just set to low and not pointing at the right direction. Okay. One, two. Unless I didn't twist those enough. One, two. Here. One, two. And then one, two. Alright. And so the order is red, black, white, green. We got another 4-way connector. That's 5. That's 5. That's 4. And then we can probably be able to test this out now. Okay. So red slides into here. Slides into here if it wants to slide in. Tweezers, where are you? Here's some tweezers. Okay. Black. Slide you in. That is the opposite of in. Okay. White. Come on, go in. Snap into place. Okay, that's it, I guess. And green. Oh. I realized y'all can't see that. That is definitely not in. That looks like it's a little too squished. There we go. No, wait. There we go. Okay, cool. Alright. Now we should be able to plug this back in and test it out. Let's see, where's the voltage for this? Okay, so that goes in that way. And now we can test out if this works. Okay. And then that's yellow, and this should change to green when this is popped on. It does. Okay, cool. And then let's try calling hydrate now. Hydrate. Okay, something's not working with the... Oh, this isn't even plugged in. That'd explain it. Okay, plug you back in. And let's see if you work now. Hydrate. Something's not working. Let me go pee real quick. Okay, I'm back. And I got a nut bar because I'm slightly hungry. But let's see why hydrate is not working right now. Let's see. Because we do have the LED changing, which is a good thing. Get the LED in view. Yeah, so the bottom LED is turning blue, which means that we are getting the command, and it is dispensing properly, and it knows that there is a cup on there. It's just not actually dispensing, which is making me think that something's not plugged in properly. plugged in. Probably just in the wrong port. Okay, let me look up the P32S3 pinout dev board. Okay, GPIO 15 is labeled pin 15. So I'm not sure why that's not outputting correctly. Let's see. We'll just sanity check if we... Okay, so if we directly connect this to power, then the pump is clearly working. Just don't know why pin 15 is not outputting what it should be outputting. Unless it's like partially unplugged. Let's try again. It says it's dispensing, but it's clearly not. And we did confirm that the relay also works because we are turning it on via the relay. Okay. D15. Why aren't you outputting D15? Oh, you know, maybe... Is that supposed to go to ground? No. It is supposed to go to ground. Just checking, is everything here still plugged in? Yeah, it is, because by shorting that, it is working. So the relay is working, just not being activated somehow. Relay in pin. And is that actually the correct... Oh! Rip. I'm on the wrong... I'm looking at the wrong project and the wrong source code. Yeah, this is the MacroPad source code. This isn't the water thingy source code. Okay, okay. Let's go to the proper project then. Okay. So the pump output pin is 36, not 15. That, okay. Let's see pin 36 then. 36 should be that one. And then let's type in hydrate. Okay, it works. Let me change the camera just so that we can show that. Hydrate. Yep, we're hydrating. If you saw that little bit of splash, that is actually why I want to keep the electronics away from it. But yeah, okay, we have functionality again. That's good. Yeah, and so we want to start adding the new features that I was talking about. So let me go clean this up a little bit, because right now it's kind of messy. And, I think the first thing that we want to do is, well, let's go back to the to-do list. Okay. To-do list. We have move the electronics up. So I think the ultrasonic sensor and the beeper are the two things I want to add right now. And the single USB port thing also. And I want it to be USB-C, because USB-C is just really nice to work with. So, I'm going to find where my loose USB-C ports are. Because I'm pretty sure I have some like USB-C breakout ports. I do. Okay, yeah. Here. And so, these will only supply power, they won't supply, like, data. But that's okay, for now. Just need to find a good spot to put, well, no, actually we can just use a solid core wire to figure that out. And we can use red and black also. Okay. So red, black. Okay, so that goes in ground and into voltage. And let's rotate that. And also move this so you can actually see that. Okay. Oh, well, I'll just do that one later. Okay. There we go. And then power. Okay, cool. And then I think I want to trim that down a little bit. Okay. Cool. And then strip these and check the pin out on the ESP32. Make sure that we can power it through this. We can. Okay. Oh wow, looks like that didn't actually stick. Let's fix that. Because the black wire is just rolling around all loose and stuff. Never actually bonded to the pad. Okay, that's more secure. And let's see what happens if we unplug you, and then let's see. .5 volt is gonna be let's try plugging that in. Yeah, that works. And we can power the pump off of that, but let me just try hydrate again. Oh. Yeah, that's the thing is, since that was already on there, it's not detecting the cup calibration properly. Okay. Let's try hydrate again. Hydrate. And we are dispensing. Missed it because the camera transition took a bit, but it worked. Gonna drink that. And then finally, I think I want to connect, I definitely want to connect the USB pump to the power source so that we only need to power off one USB port instead of a bunch of stuff. So yeah, let's just chop that off. Strip that end. And I just want to crimp it. Okay. Couple male DuPont pins. Yeah, you can do that command from the chat. Although right now it's not plugged in, so it's not gonna work. But it will work when it's plugged in. Okay, so crimp this. The other one. Yeah, the goal of this machine is not just for this stream, but for all my streams, that my chat can type in the hydrate command, and then it fills my cup with water, and I have to drink it. Okay. Alright. Is that in? That does not feel... Yeah, that's not in. Okay, let's pull it through better. There we go. And then this end, and then make sure the hot glue gun is hot. And then we can solidify it in there. Okay, cool. Let's fold this down a little. Yeah, that's hot. Okay. We need more sticks. Hot goon gun. And then, just because this keeps getting unplugged, let's glue you in. And may as well glue you in. Yeah, that'll work. Okay. I don't actually know what that was there for. Oh, that's 3v3. Okay, yeah. That'll work, Alright. Cool. So, let's test this out again, but this time, we have the pump plugged directly into, I guess, sharing this USB port instead of running off a separate one. Okay. We are on. I don't know why the screen is not turning on, because this is supposed to help us measure how much power is being used. Okay. Let me go freeze it on the workbench camera. Okay. So, let me type hydrate in again. Oh. It's because we rebooted it without the glass. This is why we're adding that other feature with the ultrasonic sensor to detect if a glass is actually there first. Okay. Now there's no glass, and now there is a glass. And let's try hydrate. Yay, it works! And it's all powered off just a single USB port now instead of 2. So it's a lot more self-contained now, and that's great. Alright, so let's see. Ultrasonic sensor, I guess. Let's work on that, but right now this is really cluttered, so I'm gonna clean it up a little. Okay, so that's put away. This driver is put away. Sticking that in there. Go in there. Go in here. Hot glue gun. Keep you out of the way. Oops. Drop the OmniFixo. And then... Okay. So, what's next? I think next... Oh! Hydrate! Yay! Time to drink the water! Okie dokes. So next is to integrate the ultrasonic sensor so that we can check if a cup exists or not. And let's see, we need at least 4 wires going on there. We need power, ground, of course, and then 2 data wires. So let me go get that out. And yeah, that's probably long enough. That's like what, 400, 500-ish millimeters. And yeah, let's just use the same color scheme that we used on the other one. Oop, hot glue gun just fell. Or actually, no, let's do a different color scheme. Let's do, instead of white and green for data, let's do yellow and, blue. Just so it's different. Okay. Oh, that'll be long enough. Okay. And let's crimp those again. Keep this out of the way, actually, so that, don't get, like, stray insulation or whatever inside in the cup, and then drink that, which was probably not good. It's definitely not good, but it could also be bad. Yeah, ultrasonic sensors are cool. Like how they look kind of like 2 eyes, almost. You can make, like, faces with them. Yeah, I could see that being really useful for, like, drone landing stuff also. Okay. And since this has male pins out, I'm gonna need 4 female pins on that. crimping wires. Well, maybe I should actually, because it's been too wide to fit sometimes in, so maybe I should be using the step below that. What's going on with this one? Okay, let's see if we actually do the step below the one I've been using for the outer one. If that actually fits in better. And then final one. Yeah, I remember I had a Fitbit that had a barometer for telling how many stairs you went up and down. I can imagine that the ultrasonic sensor is more accurate though than the barometer for that. Alright, let's get another connector with 4 thingies on it. And what order are you supposed to be? Red, 2 data, and then black. Okay. Red. Oh yeah, using that other side is way better. Though, why is it not snapping in place? Tweezers, where'd you go? Oh, I think it's upside down. Yeah, it was upside down. Okay, red. And black. Okay, yeah, I should be using that other size then. And then we'll figure out that part a bit later. Okay, cool. Let's see. Alright, so this goes down here. Okay. And then I guess that we need to add some male pins here so that we can actually plug it into the breadboard. Now, there will be the issue, though, where we can't actually trigger the pump from the, we can't trigger the pump when it's plugged into the computer, because for some reason, this dev board doesn't have, like, a clean 5-volt out, which the documentation says it's supposed to. And as long as we're also plugged into that shared thingy, I don't think that we can actually power it separately either. Otherwise, it just might get messy. I don't want to, like, create, like, a ground loop or something weird. But we don't need that. We don't need the pump to work in order to get this ultrasonic sensor working. Okay. One. That was crunchy. 2. 3, and 4. And then put some single pin sleeves on that. 1, 2, 3, 4. Okay. So, does this thing need 5 volt or 3.3 volts? And what library should I use? So, let me go check the data sheets or some documentation or something for that. Okay. Automatic camera. And, share the screen. Okay. So what ultrasonic sensors? HCSR04. Tutorial. Yeah, that should be a good source. Oh wait, actually I don't like the Arduino ones because they usually just want to use like all the internal tools and stuff instead of like external libraries. Okay. So this wants 5 volt power. You know, actually, let's just try plugging it in into both at the same time, and if it's not happy, I'll just have to grab another board, but it should work because I've done it before. I'm just a little overcautious about doing it because it just feels a bit wrong sometimes, I guess. Okay. So if this is powering the pump, and then don't do the magic smoke thing. Okay, that looks fine. Okay. So let's have... Oh no, is this long? It's barely long enough. That's kind of scary. I think I'm just gonna unplug everything. So this does need 5 volt, I guess. Let's pull off that hot glue here. And also maybe not route that in between all that because it's kind of janky. Okay. So that goes there. That goes there. And then this one can go here. And then let's re-hot glue. Ouch. Let's re-hot glue in that stuff. This goes here. We can glue it on from this side. And then we just need to figure out where these go, and honestly, it probably doesn't matter. So I'll just put it into, yeah, sure, 4 and 5. Okay. Now let's plug you in, and let's plug you in. And we have these for status. Okay. Alright, so let's start hello worlding this ultrasonic sensor. And let's go find the library for it too. Oh. Oh, I guess we don't actually need a library for it, because it's just using the pulse-in stuff. Okay, cool. Alright. Why is my tracking going absolutely insane right now? I don't know why it's doing that, but okay. Alright, so let's define some pins and stuff. Ultrasonic sensor. Or ultrasonic config, I guess. Okay, define trigger pin. I think that's 4, and define echo pin 5. And let me just confirm that. Okay, so on here, trigger is blue, echo is yellow. And if we look at this, echo yellow is 4, trigger blue is 5. So does that line up with what I wrote? I actually completely forgot what I said. I'll just remember one of them. Okay, so yellow is echo. Yellow, echo 4. Yellow, echo 4. Yellow, echo 4. Okay, I have to switch those. Okay. Long duration, long US centimeters, and I'm not going to be using inches for this. Okay. So let's define void initialize ultrasonic pin mode US trigger pin output pin mode US echo pin input. Okay. And then this loop looks pretty simple. Let's have it do void ultrasonic and yeah, just copy paste that. Trigger pin, trigger pin, trigger pin. I don't know why we're setting this back to input mode, but okay. Because it's always just input mode, right? We don't change it. Well, I guess it can't hurt if it's in the example code. And then I'm just gonna go blindly trust that. Oh, we need to also record the length of the signal back. And then don't care about inches. And then I don't know where we're getting that 29.1 number from. Okay, so that's the speed of sound in air, I guess. Or some number derived from that. Yeah, okay. Just do serial print USCM. Alright. Okay. And And let's see if that works, and then that means that, I guess it's not gonna... Oh, forgot to actually put that in the loop. Okay, so loop. Let's have it just do that here, and then upload and monitor. So on the left, that's Sea Lion. It's the JetBrains IDE for C++, and I'm using a Platform.io with it. But the workflow is going to be pretty similar if you're using Platform.io with Visual Studio. Okay. Was that the correct output? Okay, yeah. Okay, debug log. We're getting 0 centimeters out from this. Yeah, it's not reporting anything. Okay. So that's not working correctly yet. Let's make sure that we did that correctly. VCC, trigger, oh, wait. Huh. Okay, the firmware did upload correctly. Okay, let me just make sure I have the correct pinout. Okay, 4 is yellow, and yellow goes to echo. 4 is yellow, and that is echo. That is correct on here. Set up the I actually don't think we actually initialized the ultrasonic sensor. Now I think about it. Is that even the setup code? Initialize pump, initialize... Okay, I think it's because I forgot to do that. Alright. Do you get anything out here? Hello, load cell initialized. Connecting Wi-Fi, current weight. Connected to Twitch. 0 centimeters. That's not nothing we want. 0. Huh. Still not changing anything here. Okay, I think I'm just gonna go simplify it and just copy paste this example code. Okay, so was it trigger pin was 5, echo pin was 4. And let's kill that program, and let's just get that running. Oh yeah, that's also a good idea, just to output the duration, see if that changes at all. This is taking a while to compile. Read ultrasonic, where'd you go? Okay. Compiling, compiling, compiling. This is taking longer than I thought it would. Okay. Let's set this to that. Though, why doesn't it want to talk? PO device monitor. Oh, that baud rate is off. Let's set that to that temporarily. Change that back. Yeah, it's not logging right now on this new program, so that's what I'm trying to figure out right now. Okay, what if we just hit the reset button and see what that does? And are we on the correct port? We are. And serial begin, that is the correct thingy, the correct baud rate. Okay, I'm just gonna go back to here and just try logging the raw duration. Print duration. Print that. And let's see what this does. getting any kind of number out of here. I also want to check if we're getting like any voltage to the ultrasonic sensor. Okay. Load cell initialized. Connecting to Wi-Fi. Is this changing values? It's not changing at all. Okay. Let me go make sure that we're actually getting any voltage out and check continuity. Okay. Stand that up and let's turn the light on. So y'all can see that. Okay. We are getting 5 volts. Let's check continuity from trigger to oh, we're not actually getting any continuity. And then other one, echo. Okay, well that kind of determines it. Huh. Okay, that's really weird. Let's move it to maybe port 6, or pin 6. Okay. Hello world, load cell initialized. Huh. Okay. You get anything here? We're still not getting anything. Okay, so blue is trigger, and trigger does not seem to be working. That is weird. Move that to there. But why doesn't it work in there? Okay, whatever. Let's just move it to whatever that next pin is. And that next pin is 7. This breadboard is whack. Can't wait to move it to a perf board. Okay. Load cell initialized. Connecting to Wi-Fi, connecting to Twitch. Yay, we're actually getting some numbers out. Okay. So it says that there's 28 millimeters from here to here, which is a little off. I want to say it's probably more like 25 or so. 28? Oh no, that's even shorter. Yeah, because 28 would be, well, unless it's actually just measuring this corner instead of here. But yeah, okay, so let me maybe put on half and half view. Okay. Half and half a view. Hold on. GoPro desk. TV, don't want to show you. Okay, cool. Yeah. Alright, so let's see. Where is my ruler that I just had? Okay, so here's the ruler. And it's gonna be just slightly off, but that's okay. Okay, so, oh, I should probably tilt the camera over. There we go. Okay, so we have the ruler and we have the ultrasonic sensor. Right now it says that the thingy's like 48 centimeters away or so. Wait, did it stop going? No, it didn't. Okay. So, let me go get something. Yeah, let's just use this one. Okay, so, this should probably report about 8 centimeters or so. Yeah, that's correct. Then here it should be about 28 or so. 29, yeah, that's good. Here should be maybe like 16-ish. What does it say? 17-ish, yeah, that's good. Okay, so yeah, we can detect if we have anything on here now. So I guess that means that it's out in open air. Let's see if there's like a way we can aim this so it's just kind of going into the void. It looks like that we're maxing out at just under a meter here. And that's good because, okay, so if there's nothing, then it's like it's like a pretty long distance. And let's see, if we get up close, we get 2 centimeters, and if we totally block it, then, okay, then we're at like some really ridiculous distance because it can't actually sense anything because it's not, I guess it's not pinging back or something. But that's why I extended the scale out to be like out here a bit more, because before it'd be like a little too close. So if the cup was all the way at the edge in the old location, then we'd actually be reading that there's no cup here. But in the new location, if we put it all the way at the edge, it says that it's 4 centimeters away, which means it exists. So if there's a cup that exists, it'll read between 4 and like 3 or like, I guess 2 to like 7 or 8-ish centimeters. You can have like a buffer zone for that. But yeah, we can now sense if there is in fact a cup there on boot up. So now that that works, we can modify the program so that it doesn't actually take the measurement until the cup is taken off. So let's go back to the desk view. Alright, so where are you? Initialization stuff. Read weight. Initialize ultrasonic first. And then we want to do this at the initialize load cell step. Okay, so let's have it read ultrasonic. And we should probably have it so that that's like void read ultrasonic. Okay, so while US centimeters is either so while it's smaller than 2, and if it's greater than, say, 10, and what does it initialize to? Let's have it, or we don't need to have it like initialized. We need to have it like set to like 0 for now. And then maybe let's have it do like serial print line, no cup, or no, actually we want it to be, yeah. Okay, so this is that we actually want the opposite of that logic. So there is a cup detected if if the ultrasonic reading is between 2 and 10. Please remove, or cup detected, please remove cup. And actually it'd probably make more sense if we just defined that here. Define glass distance minimum 2, and define glass distance maximum is 10, and then this is on scale by ultrasonic sensor. I've actually never defined a property in C++. How do I do that? Oh, actually I could just probably write a function for that. Okay. Bool class is on scale by ultrasonic sensor. And then if, or return is greater than glass distance minimum, and I'm not actually using the correct capitalization scheme that I wanted to. So let's refactor that. Oh, wow. It was gonna fill. Oh, no, never mind. Maximum. Okay. That's a little smarter. Alright, so let's upload that and see what happens. And let's go back to the halvesies view. Why did that make my mocap go nuts? Okay, so when no glass is detected, then we are detecting that. Then we are able to proceed. Now, let's see what happens if we reboot this when the glass is on there. It should tell us that the glass is on there and that we want to remove the cup. Huh. No, it's not repeating it. It should be repeating it. Okay. Initialize load cell. We should probably make this, we should probably add a delay here. It's over the minimum and over the maximum, then that means that a glass does exist. Why is my mocap going crazy? Okay, what if I move this out of the way here? Okay. Nope, that didn't work. Read ultrasonic. Are we actually setting stuff? I need to go pee again. Let's go back to initialize load cell. What if we just increase that delay and... Oh. Huh. Let's actually set that to like maybe 5 or something. Oh, and wow, my iPad is about to run out of battery. Let me charge that. Okay, let's go back to half and half. Okay, I think this is actually working now. Have these. Please remove cup. Just repeating that over and over. It is refusing to initialize. And we are well within these zones. Let's actually change the minimum to like 1. Oh, wow. Yeah, we need to set the minimum to 1 or else it could potentially have a false negative that the cup is not on there. So let's upload that. Alright, cup is detected. Please remove cup. So yeah, it's just gonna keep whining about the cup being on there, which is exactly what we want. Once the cup is removed, then it looks like we can actually proceed, I guess. Load cell is initialized. Status no glass. That is correct. And then, when this is on here, says that the glass exists and it is partially filled at 1%, which is okay. And then we should be able to type in hydrate. And when we do that, water is dispensed. That is what we want. Cool. Okay, so we have the ultrasonic sensor blocking the load cell stuff. But, you know, maybe we don't notice that because it's silent. So let's get the beeper working. Okay, let me look up the beeper stuff. Okay. Arduino beeper tutorial. I like the random nerd page for this. And we could probably just use that. Yeah, that's the same thing that we're using. Do we need a resistor on this though? Random nerd. Let's just use the buzzer tutorial. Oh, can we use tone on the ESP32? Okay, well, let's see. 100 Resistor. Wait, why do you need the resistor? It doesn't actually explain anything about that. Okay, so one of them goes to ground and the other goes to just some output pin. And it might need to be a PWM pin, probably. So ESP32, S3, pin out. Are all these PWM friendly? Wow, they're pretty much almost all PWM friendly. Okay, well, that makes things easier. Alright, so this breadboard up here, let's connect it to stuff. Okay. So I think this is my solid core wire. Yes, it is. And one of them goes to ground directly, which is nice and easy. Okay, you go to ground. And then the other one, we'll just have at some random output pin, I guess. Yeah. Was that long enough? Oop. That was close. Okay, so this row of stuff. And then let's try the neighbor of whatever that one pin was. So that's probably pin 7 or 8. Which GPIO 15. Okay, it's gonna be 15, I guess. Okay. Buzzer config. Find buzzer pin output pin. And that is typoed. 15. Okay. So do we have the Arduino tone function? Void initialize buzzer and pin mode buzzer output pin output. This is very simple. We can define it down here. We should really be defining all these functions down here anyway. Setup. We can make it like the first thing that gets initialized. And then we can just actually have that in here. Delay 50. And then, do you have tone? I guess we do have tone. Okay, that's cool. Yeah, let's send a 1K signal. Delay 1000. Tone. Oh, no tone is a thing to turn it off. Okay, let's see what this does. We should get a beepy sound. Why does my mocap keep doing that? And let's go attach this microphone up here so that we can hear those beepy sounds. And let's get a half and half mode. Cool, we got a tone. Yeah. Okay, that's good. Okay, so I'm thinking that we have it just yell at us anytime we need to get that, what's it called? We have it yell at us with that buzzer whenever, that cup is on there. So, where do we initialize that load cell? Okay. So, let's do no tone. Buzzer output pin. And let's define buzzer class calibration warning. Let's make it just 1000 hertz. Tone, buzzer output pin, buzzer class, blah 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 blah, and then we can make it go to no tone. Okay, so now it should start screaming at us whenever, it should start screaming at us if the glass is on there until we remove it, and then it should be able to initialize properly. Huh. That's not working. And why is the duration set to 0? That means that the ultrasonic sensor is not working anymore. Did we unplug something by accident? You may have unplugged something by accident or accidentally changed some pin. It was working! Okay, continuity check again. Yeah, because that duration is reading as 0 again, which is the problem that we were having earlier, and that's not fun. Okay, so... yellow. Apparently that's not connecting anymore. And then... is this even, like, beeping? Yeah, it is. What the fuck is happening? Ugh. Is this just being, like, really, really fickle? Okay, now it's working. I think the issue is just not staying plugged in. Which will be fixed when we, like, directly solder it eventually, but... okay, so let's try again, I guess. Please remove cup. And it's still continued though. Oh, no, that's actually supposed to be how it works. Okay, what about now? Please remove cup. It will not initialize until the cup is removed. Now it's removed, and it can initialize. it back on. And this should turn to green, but it's not. Huh. Okay, it looks like that we're actually not setting the load cell afterwards, though. Okay, let's maybe set that to like 1 second after. Okay, upload and monitor. Let me drink this water. Okay, writing the program. You know, this might actually just be too close to that. Maybe we should set that max distance to like 8. You also could just screw the breadboard and just like solder direct to it. Okay, I don't really trust that anymore. Let's just solder directly to it. Okay, so you will be stuck at 15 here. And then... how do I want to do this? I'll just slop off the ends and just directly solder to those pins because it's being really annoying right now. Okay. So let's solder this. Can y'all see that? Let's pull this down. Unplug it, because you know that sometimes I can start to freak out if stuff is like plugged in while I'm soldering. It's probably just best practice too. Okay, so yellow is echo, and that's 4. Let me just confirm. Yeah. Yellow is echo, and that's pin 4. And then pin 7. And then we should stop getting like disconnections now. Okay, let me plug this back in. this in. And then hit the reboot button. Okay, PO run, or no, PO device monitor. Okay. Cool. Then let's see if we reboot with the glass still on there. It should start screaming. Unless it... Okay. Cup detected, please remove cup. Why is it not screaming, though? Is this not plugged in? We're having the same issues with it not staying in the breadboard. Okay, we can just solder this too. That is pretty toasty. Alright, that should be enough. Plug you back in. Okay, now it's screaming again. That's what we want. Probably get those debug logs again. Cup detected, please remove cup. Cup is removed. And now it's balancing the scale. Okay. You can tighten up those times and polish, but that should work for now. It says that there's no glass, though. That's kind of broken. What if it's on that end? Maybe you can lower that glass mass a little bit, since we've been on the edge anyway. Is it uploading? Something else is using it. Oh, wait. Oh, it's still here. Okay. Let's upload that. Okay, so right now it doesn't think there's a cup there, except at the very start. Where I just clean up that routine a little. Okay, there's no glass. Let's put the glass on here. What? Why is it saying that there's like... get unplugged. Huh. Maybe these connections are not good. Okay, I think something just went, like, unplugged for a little bit. Let's try again. Okay, load cell is initializing. So there's no glass. Let's put this on. Now it says we have a glass on here. Okay. Alright. Now let's try hydrate. You're dispensing water. Okay, cool. Alright. Let's see. Okay, let's go back to the iPad and see what we've crossed off the to-do list. Turn screen off. Okay. So we have the single USB port thing working for power. We raised electronics. We added a beeper for alerts. We integrated the ultrasonic sensor. I think the last thing, maybe, because honestly I'm starting to feel a little bit under the weather, so I think I'm going to start to end the stream kind of a little bit earlier than I wanted to, but I do want it to make a sound when it's dispensing water, so... Buzzer, dispensing water. Let's have it be at, like, maybe 2K hertz. And where is the trigger pump thing? Where are we actually setting that relay on? Unless we're doing it in a bunch of these places. Okay. Tone. Oh no, that should be pin, buzzer, dispensing water. It should be no tone. And then same here. Okay, let's upload that. Right now it's screaming. Oh, that's weird. Oh, wait, what? Huh. Why are we not uploading now? Why is upload broken? It's not broken now. Okay. Okay. So, cup. Now it's initializing because there's no actual cup on there. But there's also no glass now. Okay, now if you put this on here, partially filled glass, and let me set it back to half and half. Hydrate. Okay, yeah, now it's beeping every time you hydrate, so that's cool. Yay! Okay, cool. Alright, well, starting to feel a little under the weather, so I'm going to end the stream a bit earlier than I wanted to. But yeah. Okay, well, if you haven't joined my Discord server yet, I'm gonna go post my Discord server link in here, discord.pearlgrey.io. And yeah, we have a hydration thing working. Let's hydrate again. Because hydrating is fun. And then it'll probably pick up the YouTube one a little bit later. Come on, YouTube detector, where are you? Is the YouTube chat one working? Okay, yeah. Yeah, it has like a 30-second delay. But yeah, let me go drink that water. All right. Whee! Okie dokes. Well, we made some improvements to the forced hydration thing. We added that ultrasonic sensor, and we added a beeper to it, and we moved some wires around so that water wouldn't splash on top of the breadboard. But yeah, okay. Well, I wanted to stream a bit longer, but honestly, I'm starting to feel kind of like sussy, so I think I'm going to like end the stream a bit early. But thanks everyone for tuning in, everyone for doing the hydrate command, and this thingy will be working on every single stream that I do, so it's not only during the hydrate stream that you'll be able to redeem the hydrate command, it'll be any stream that I'm streaming that you should be able to hydrate. So yeah. Alright, well, everyone take care of yourselves. And I am going to log off. Thanks for tuning in. Bye-bye.